again, feedback. We need a monitor for the speakers so they can see what the hell's going on. Anyway, so I'm Jduck, also known as Joshua Drake. It's not in the schedule necessarily, but not a secret. You guys here for the Stagefright talk? This is a pretty interesting one. Let's just jump right in. So here's a quick agenda. We'll talk about these things. Again, it's me. I've been doing exploit dev for a long time, VR for a long time. It was a hobby for me before it was an actual job. So, you know, after it was a hobby, I started working at iDefense and then left there for Rapid7 for a year and a half. I had a great time there. And then went to Occupon Labs, which now became Optiv. And since then, I left and went to Zimperium. So now I'm the VP Platform Research and Exploitation there. That means I am in charge of understanding the mobile ecosystem, you know, security features of the platforms and how they might be vulnerable, how to make those better and stuff like that. So also founder of DroidSec Group, which is actually, at this point, has several Google people in the channel, which is pretty cool. Actually, I saw them working things like together, like in the channel, and I was like, okay, that's really cool. Also, a lead author of Android Hacker's Handbook. If you haven't read that, it's really out of date now, so screw it. Some things still make sense, but. So the motivations for this talk were really to explore the difficulty of exploiting vulnerabilities on Android, in particular using Stagefright vulnerabilities as a example. I did a talk here last year that was about Stagefright vulnerabilities, and it was more about the specific vulnerabilities. This one is more about exploitation of those. I really wanted to get more. I want to get more people involved in vulnerability research in general. I did a talk at DEF CON with Steve Christie, who was the pioneer of CVEs, if you've ever heard of those, and also did a lot of work on CWE and a lot of other MITRE standards. But you know, we did this vulnerabilities 101 talk to try to get some of the more new people in the industry interested in and familiar with the kind of key concepts of vulnerability research. So, of course, like I said, I did talk last year. It was kind of a big deal last year. It made a lot of things happen inside Google. We'll talk a little bit about some of those as well. So, acknowledgements. I always like to do this. All these people help me with various things. Obviously, DerbyCon gave me the opportunity to present here today, and I like to just give everybody a hand if you guys don't mind. Like, I really think, you know, collaboration and working together is how a lot of really amazing things are going happen. It's sometimes like credit doesn't get given where it needs to, and I think that it's important to do this. So I do this every time. It's like I keep trying to remove slides from this slide deck, but that one I just don't want to delete. You know? So what is Stagefright? If you haven't heard of it, it's a multimedia library inside Android. It's primarily written in C++. I think pretty much all of it's C++ actually. It handles all the video and audio files for playback and also for metadata extraction. So things like the dimensions of the video or perhaps the duration or, I don't know, anything you can think about that's not the actual video frames. And that stuff's presented in the gallery or it's accessible through the Android framework through various APIs. And now at this point it's also under the name of a vulnerability. You can check out the Wikipedia page, which I had nothing to do with, but it's actually pretty good. They did better at describing it than our marketing people did, so that's cool. Yeah, and so when we published this last year, you know, at that point you could actually through an MMS compromise a device and get access to this process called media server. Media server then had access to the microphone and the camera and basically everything that you would think about in a phone that does media stuff. So that was pretty nasty. They fixed a lot of that. Let's talk a little bit about this vulnerability that was exploited. It's kind of embarrassing because it was a vulnerability that was found in a line of code that I patched with the CVE 2015-3824. I missed something, and so that's why, again, it's important to have collaboration. It's important to have code review. I didn't realize that I had made a mistake here, but you can see the mistake if you look really closely. The problem is that this chunk size value is actually a 64-bit number. And so size max is a 32-bit number And obviously, a 64-bit number can sometimes be larger than a 32-bit number. So yeah, 2 people reported this bug at the same time, and it was kind of embarrassing. Yeah, I'm ashamed, but I'm human as well. So why did I pick this one to write to exploit for this talk? The idea is that this one got patched 1 month later, so you get 1 month more of vulnerable firmwares. And in some cases, some devices that are out there may have got patches for the initial batch of vulnerabilities that were highly publicized, but might have missed this one because it kind of went the month after. Also, like I had written an exploit for 3824, that's what I demoed last year here, and this change is basically all it took to make that exploit an exploit for this vuln. You basically just add this 1 here pretty much and make sure it's a quad word instead of a D word. So the root cause of this one is it's basically the same situation as 3824. You end up with this thing on line 1896 where they're adding a size with this chunk size, again chunk size being 64 bits. And the new operator, I believe, only takes a 32-bit integer as its value, so anything that's bigger than 32 bits inside of those brackets on 1896 is going to cause an undersized allocation. This is an accumulator tag, so if there are multiple TX3G tags, each time one is encountered, it looks to see what it already has seen from a TX3G tag and just adds to the end of it. So you really can't trigger anything bad by just 1 TX3G tag in your file, but if you have 2, then even if the first one is only 1 byte, you can still cause an integer overflow. So the consequence of this is, just following this allocation, they have a mem copy with the amount of the new data. They just tack it on the end. So, if you had before an allocation that was only 1 byte, and now you have an allocation that's 0 bytes, and it's going to add whatever you say here onto the end, it's totally going to make a problem. And you see in 1905, that's where they're reading the data from the file. The idea being that you can control how much data is actually read into this undersized allocation because you can truncate the file at any point. So if you have only 32 more bytes, then it's going to write the 1 byte and then the 32 bytes and to the 0 byte buffer, which is really bad. Writing anything into a 0 byte buffer is really bad. Don't do that. So we basically control everything, and you can see here from the exploit where we're setting some values, including the different allocation sizes and making things happen the way we want them to. So is Android secure yet? It's really interesting when you look at, this is kind of a high level look back at what I've learned through the process. When I look at any operating system, the things that are important to me are the heap implementation. It's very important. Back in the day, heap implementation was how you could create even generic exploits against whatever. There were the write what where unlinked scenarios in the older heap implementations. Also, the ASLR quality is very important. It was previously pretty bad, and we'll talk a little bit more about that. So I'm not going to be I'm a realistic guy, and I don't believe that you can eliminate all vulnerabilities in a code base. I think you can do your best. And if you just assume that you can't, which I think it's kind of also a defeatist attitude, because maybe you can if you try hard enough. But hardening can make things at least harder to exploit. So those other mitigations are also important. But these are the kind of the 2 big ones for me, I think. Android in Lollipop 5.x, they added a new heap implementation called Jduck. This is not necessarily a new heap implementation for the world. It's just a new one for Android in L. In M, they switched to it some more in Marshmallow, and in Nougat, it remains the default allocator. And I think in Nougat, the idea is that the old allocator is actually going to be removed in favor of this new Jduck. So Jduck, I think does anybody remember the guy's name? Is it Jason Evans? Something like that. So JE is from his name, and this allocator existed for some time. It was used in Firefox. There's good presentations about it. I think I have a link somewhere here in the slides. The problem is that it's weaker in that they have less entropy in the heap addresses. Things are allocated in blocks, and they just, can we like turn the volume down a little bit so we don't get so much feedback? Test. You heard the feedback? Okay, so, hey, that's much better. So that means it's easier to guess where your data is in memory. If you have huge allocations, they're very, very predictable. They also got rid of inline metadata, so if anybody has anybody ever done like heap corruptions with dlmalloc or any of the older kind of allocators? Yeah, Atlas has. Dave. Sorry guys, I'm a little nervous after all that fiasco with the freaking browser window. All right, so they got rid of this inline metadata, and the thing is that the inline metadata actually makes exploitation more difficult. So way back in the day, they had the unlinked technique that was very easy to exploit, but after that whole scenario finally eventually played out to, all right, you're gonna make me drink this thing? You guys are nuts. It's hot iced. Hot ice, oh shit. I'm gonna try not to vomit right now, so I'm gonna keep that for a little bit later. So that means like after they had this unlinked technique mitigated, they basically started checking the pointers and they wouldn't write to them if they didn't match each other. So that means then if you ever corrupted them, then things would crash instead of actually corrupt memory in a very nice way. So in switching to this new allocator, they got rid of that. So that means that there's nothing in between. When you overflow from one block into another block, there's nothing that can detect it at all, and it's just application specific how you would exploit it. And in a C++ program, that usually means you just hit a vtable. We'll get into that a little bit more. So unfortunately, that's the situation on Android today, and I actually run my device with a different allocator, so good luck with that, guys, if you want to own my phone. I don't like JMalloc. So here's a little mitigation summary of these different things. SE Linux is present since 4.4 and enforcing in all modes since 5.0, but it only really comes into play once you get arbitrary code execution. It's not really any consequence to you if you're exercising code that has vulnerabilities in it. Stack cookies are completely unrelated to heap vulnerabilities, so that doesn't apply. Fortify source also only works when the compiler knows exactly how big buffers are, which you can imagine if it's a dynamic size allocation, it never knows that. So it doesn't come into play. ASLR is only present really on Android 4.1 or later, and it's actually pretty weak up until NuGet. NuGet improves it quite a bit, but we'll talk about that again some more. So NX is, it's well known. Once you get around ASLR, then NX is not really a concern. You just use return-oriented programming. And then there's this new mitigation in GCC 5.x where they're actually checking the parameters to new. That didn't come into play here because the integer overflow actually happens before it even calls the new operator. So that didn't come into play here for this full. So ASLR, 3 exploits that I developed. I think actually it's more like 5, but there's a couple that are not so, they're just kind of variations on the others. The first one was 1538 on Android 4.04. So I did that because I thought, hey, this will be easy to exploit because there's no ASLR here. It ended up being actually much harder than the 2 exploits I wrote for Android 5.1. And so I talked a little bit about this number 3 exploit at ISSW this year. I don't know if we released slides or not, but they may be on my personal website. If you're interested in those, it's a different exploit than this Metasploit module, but I guess we'll get in the next slide, right? So, well, not yet. So, so Metaphor happened. Anybody heard of this Metaphor thing? These couple of Israeli guys, they were playing around with this vulnerability in the browser, and they discovered that they could use some JavaScript to read the duration field of a video tag, HTML5 element, and they use that to basically corrupt some stuff and then use that as an arbitrary read for certain values. And that's cool, except, well, let's get a little bit more, I guess, huh? So, and that works through using these metadata items. And inside of the MP4 code, they use this class called the metadata class. It's a special kind of vector that is sorted. So anytime you add something to it, it's always going to be in alphabetical order. And so what they did in their technique was they overwrote a height tag, which is kind of usually the first one, with the duration tag. And they wrote a pointer in the last bit, and so because this value is controlled by the attacker, they can read whatever they want. So that's pretty cool. The problem is that you know, obviously the metaphor exploit was eventually released after the paper. In the paper, they said they supported a whole bunch of devices and firmwares, and then their exploit came out and it supported one device and one firmware, and that was kind of disappointing. But the thing that really sucked when you read the paper is that the leak method has some really crappy limitations. You could only leak values using a double, which I don't know if anybody has ever used doubles in exploits before, but double precision floating point numbers, they pretty much piss you off whenever you have to use them. I think something about man. Yeah, it's not a number. But is it? It is. Not a number. So there's that problem, and then at the end of it, they do some math on it too. So that means you can only leak values, 64-bit values from memory that have their high bits set to less than this 512, 511-ish number. Then also there's some precision loss because of rounding and such, so you don't get the low bits at all. So you get none of the low bits, and you get nothing that has the high D word of greater than this. You could imagine that kind of rules out vtables and a lot of other things that have big numbers there. Or, you know, even though the process is 32 bits, usually you're not going to get a vtable that has the following thing be something small, and we'll talk some more about that. Also, their exploit required like tons and tons of requests. I finally got it up and running. I put the browser to it, and it was just like loading. A media server crashed. Oh, great. Loaded, and then media server crashed. I'm like, okay, well, that's not going to work. That's my other exploit that was really dumb and just use a nasty big heap spray. It worked much better than that, I think. So I was like, let's not use that technique. I don't think we're going to have to do something else. So I was like, what about the height and width? They mentioned the video height and the video width in their paper, but I can't remember specifically what they said in there, but they didn't end up using that for whatever reason. It turns out that these metadata items can actually be controlled in a great way and still be read. There are some limitations to this technique, but it's not something that you can't work around. So basically there's some checking to make sure that certain values are not gigantic or whatever, and then if you can avoid that, it's okay. It's a lot better than the double precision floating point numbers. And so what we come up with is a new technique here to, we can change the size of a metadata item by overriding it only partially. We can change the type of it and cause it type confusion. The only thing that's really tricky is dealing with how the array has to be in order. The vector has to be in order. So it's kind of like, you can see here in the bottom, my answer was just to put some ABCs up in the front. Even though they're not even used or supported, it doesn't matter as long as things are still in order. And so, oh yeah. So in this case, we've changed the MIME C string to a height tag. You can see there used to be a height tag, but we got rid of that height tag because we don't like that one. That one says, 1024 or something. That's not fun. So we changed that to a 32-bit integer that has, well, it overwrote the MIME string. So we didn't overwrite the pointer, so this means now the height value that we return when we read it from the HTML5 tag actually is the pointer value itself, which you can imagine is not, it's not like a very sane value, but you get the whole value, so that's the important thing. and it's very precise. And we can combine that with other stuff, like this HVCC tag is actually an allocation that you control the size of that's filled with entirely your controlled data. So you can allocate those and leak the pointers of them. So another interesting property that I realized. So at first I'm writing this exploit and I'm like, hey, this isn't going to work, right? Like I'm going to make this, I'm going to process a single file and it's going to do all this stuff and then I'm going to leak a pointer and that pointer's going to be stale. So I'm going to end up with this crappy buffer that's, you know, maybe not having what I want it to have in it whenever I get the address of it. So I thought, well, that won't be very reliable. It's going to suck. So I was like, I'll just try it anyway and see how reliable it is. And then I figure out like, oh, hey, actually when the browser talks to media server, they never disconnect from media server. They just connect whenever they need to initially, and they stay connected, and they do multiple requests to media server until either media server crashes or until you close the browser. And so what that means is that no allocations are getting freed. So everything stays there, you get the pointers, they're all completely valid, and it also is really bad for leaking memory. So if you just want to have a JavaScript page that just loads a big file over and over again, it'll eventually run media server out of memory, or maybe even the whole device. So we know we can leak a pointer, we know it'll be alive. That's a really powerful primitive. So the question is, how do we get a code pointer? Because if we're going to do dynamic ROP, we need to know where some module is, and we need to know what that module is so we can create a ROP chain. You know, the normal thing you do is leak a vtable, but as I mentioned before, the read primitive that we had with the original metaphor exploit doesn't really allow you to read the typical stuff. So a vector is kind of, I don't know if I have the, yeah, there we go, cool. Made some pretty good slides. So they've been useful, metadata items have been useful here, but they're not going to help in this specific case because metadata items never really point to the code. They're just a very simple data structure, as you saw with the 4D words, and that's really it. You're never going to see anything in there. And the pointers that point off to whatever the data items for those metadata items are, they just point to just raw data and usually control those. So there's not going to be any code pointer there. So we can't use these directly. But after a while, I was looking around and I'm like, hey, they have all these different specializations of a vector impl or a vector implementation. And obviously it has virtual methods, so that's great. We want something with virtual methods. So they have a vtable pointer there. But the first two fields are the vtable pointer and then they have this mStorage field. And so mStorage is really like, it is those items of, 4D words that are one after another in memory, a contiguous block of the actual vector storage. And so the thing is, whenever a vector is allocated, and it's usually initialized with some initial value, like maybe just a 0 in there, or they will pre-allocate a certain amount, saying like we expect we're going to have at least 16 of these or whatever. And so that means we can't use the metaphor leak technique because we're always going to have a vtable pointer followed by a pointer to some heap memory. Those are both numbers that usually are starting with high bits that are, very high, like B or F or whatever. And so the leak just won't work for that. So I was like, well, what the hell am I going to do? I need to leak vtable. So I keep looking. And what I find is this one object that's a vector that's inside of a sample iterator. It's kind of like smack in the middle of the object. And it turns out they did not initialize this one. So they initialized the main object, but they never pre-allocate the size of the array. That's actually never even used unless you have some other specific tags inside the MP4 file. So that means that mStorage is null. So mStorage's default is null. Without it being initialized, that means now I can leak the vtable pointer. So that's a big win, right? Like we have everything we need. We can leak code pointer, we can leak a heap address, we can put stuff in memory that we can find out where it is. It stays there forever as long as the browser's alive. So that's all wonderful. So then I put it all together and built a two-stage leak with that creates the ROP chain from libstagefright itself, because that's where this sample iterator object is implemented. So ASLR still poses a small problem because In the route chain, we are going to kind of protect the region of memory where our arbitrary code will be. Just as kind of a ROP stager, we want to make it executable. It's only read-write it when we get there. And so we need to know where that is. So ASLR still poses a small problem. We also, slide doesn't make sense to me right now. Yeah. I mean, so yes, you can. This one actually used a large heap spray. It was about 16 megs or something like that. And that ended up being super, super predictable. Like, you pretty much can guess it in first try. But media server restarts anyway, so even if you're wrong, you just try again. And that's really cool. In the JavaScript, you can actually, with some timing tricks, notice if media server crashes, and then reset your process and do it all over again, which is pretty cool. Okay, so the resulting exploit is pretty fast and reliable. I'm really happy with it. I think it can be better, but we'll talk about that. So the key exploit details, this has been implemented in a Metasploit module. I think that a Metasploit is a great platform for everyone to work together and also to enable administrators and other people to test. Those people may not always be good at writing exploits or even running exploits, but Metasploit makes it pretty easy for most people, especially like the fancy ones that are just point and click. So this module supports 29 targets. It includes all Nexus devices that were vulnerable that run 5.x, meaning the ones that use JE-malloc. It automatically selects a target based on the user agent, which, as you can see in red here, the devices are very forthcoming about what version of Android they're running, very specifically. Yeah, and there's only 3 web requests needed. So, you know, a side note about Android device diversity, you know, some of the Android security guys have been quoted as saying, you know, the device diversity really helps in security, helps, you know, prevent wide scale attacks. And while there's some truth to that, I think that scaling, and I've done some work with scaling in this case, the exploit dev is not a serious problem, right? So I have an SSD with 500 gigs of uncompressed firmwares, and I just scan through and extract all I need, and then it generates this module actually. So it's not like something you can't overcome. Another great side note, this is, who's heard of the Android compatibility definitions document? I know Dave has. He must have. He works there. So this is an excerpt from it where it says, hey, you actually have to give everybody your full firmware information. That's great. Thank you, guys. You might want to remove those 2 lines that are bold. Tell them something like, put a little ASCII middle finger in there or something. So, or if you're really paranoid, you guys might want to change your user agents. So I'm actually not prepared to do a live demo because I hate the way that the screen is set up. But I know I have a window somewhere that has this stuff in it. Do we really want to try to figure out where that window is? No, we could do a live demo. Oh, hey, look, I found this window. It's amazing. It's on my screen. It might not work, but I mean, I'm pretty sure it'll work. This exploit works way better than last year. I was really disappointed last year when I tried to give the demo because the demo didn't work. I hate public live demos that don't work. All right. So the question is, how am I going to put this on the screen for you to see and still be able to type? Let's see. Yeah. Did I find the window? Where? Oh God, here we go again. Look up that other window and click mirror display. Maybe it's on the other screen. Yeah, it's on the other screen. All right. Oh no, what did I do? Escape. Yes. Do you know where the checkbox is? No, where is it? It's right here. So should your mouse. There you go. Maybe we should have done that from the beginning. Can you guys see that? Can you read it in the back? Bigger. Enhance. How about that? Is it big enough? You need some new glasses. So this uses the new metal payload. I love it. It's great. I'm so thankful to Adam and Brent for putting in the work for that. By the way, Adam and Brent have a very different approach to Metasploit dev. They actually are like, hey, look, somebody already wrote a library to do all this shit for us. Let's use it. I'm like, wow, that's pretty smart. You mean we don't have to write everything in pure Ruby all over again? It's great. So the module is up and running. I need to go to this window. We don't want to have that device anymore. Let's go to this device. So I'm going to run a command that's just going to turn the screen on. In theory, that's what it does at least. And then we'll run this shell script, or this Python script that just runs this command and tells the browser to open to this URL. And it doesn't work, of course, figures. Let's do a service, enable Wi-Fi. That's probably the problem. Why didn't it work? I did it wrong. Service Wi-Fi enable. Let's try again. The browser's probably open with some really ugly error message on my desk at home right now. Hey, it's working, hey. Oh, fucker. Seriously? So much for 2 web requests. I think there's something about demo gods and DerbyCon. It just doesn't work out. Oh no, what the hell? Now Stagefright rock chain's not available? Okay. What? These are not my commands. Who made these commands? Stagefright. I had some commands that I used earlier to like do this, and now they're gone. No, not packet foo. Like packet foo, but it's not it. When did I run that command? Like 10 years ago? I'll just do it over again, you know. So CP, Stagefright. Oh, no. It's in here. Yeah, I had this all set up, and I somehow screwed it up. Isn't that awesome? So you know the exploit was about to work, and then Metasploit couldn't find a ROP chain it was going to give to that's bad. Let's see if it works again. Oh, hey, look. 2 requests, and then the last request. So the last request happened twice because once comes from the browser and once comes from the media server. Hey! Look at that. So now we are media server. Yeah, we can't really do a lot. We can look at stuff, but oh yeah, look at that. But we can't like go in /data and look. So another part of what I've done is I put a couple of kernel exploits into Metal, just kind of like compiled them in. Yeah, and this one, it just runs them both, and if one fails, it runs the other one, but this one always works, so. And then we can just run get UID. And I think actually I would run the shell command, like, because everybody loves a real shell, but the shell command is kind of funky, so we have to do it a little bit differently. We have to use this execute, you know what, screw you, old history. Something is weird, it's like using old history of mine. But anyway, I think if we do execute, also the shell is non-standard on Android, the path to it, so we have to do it like this. And what is it, like channelize IO and interact with it? Yeah. And so, yeah, so the path is screwy, so export path equals system bin :string path. Then we can type ID and get root. Yeah, so that's a good demo. And thanks again to the Metasploit guys, Adam and Brent, for like making all this stuff work really well, and being receptive to my bug reports and requests and complaints, and not making me write the code myself. So you can see SE Linux has been disabled. We can pretty much do whatever we want at this point with this device. We could RM it, but that's not very nice. So we'll keep the exploit running, and then we'll go back to the slides if we can find them. So what about that one window where it said mirroring? Okay, so let's not mirror displays anymore. Hey, the thing's on. Oh, damn it, where'd it go? What the? Okay. Now, but where is the thing that you guys want to see over here? Is my cursor over there? So I'm going to hit some buttons. Hey! I'm getting good at this. All right, so that was a live demo. We're going to have to go quick because we're out of time. So, you know, that's Nexus devices. That's great. But what about Samsung? Because Samsung is like everybody's Android, right? Like nobody uses anything with Samsung. Is that right? Only if you have a Note 7. We just have to charge it. Don't do it on a plane. So I was like, well, hey, we need to make it work on a Samsung device. Can this even be done? It was mentioned in the metaphor paper that they thought it could be done. When I talked to the guys who wrote that paper, they were like, yeah, well, we never really got it to work. We got some things happening, but it wasn't really what we wanted. I'm like, okay, that's interesting and cool, but that's not what I want. I want it to work. So I got this crappy Samsung Galaxy S5 Verizon version off of eBay. It turns out nobody wants these Verizon devices, I think because they have locked bootloader or something like shitty like that. So they're very easy to get. But porting it was not easy. It required a lot of reverse engineering because in the Android ecosystem, the OEMs modify Android heavily. You know, with the Nexus devices, I could compile symbols and like do like source level debugging and all this other great stuff, but that's totally not possible with Samsung device. Also, debugging is harder. There's no symbols in any of the binaries, and that makes GDB pretty shitty. It doesn't know whether code is thumb mode or ARM mode because the symbols are missing, and so it puts the wrong kind of breakpoints in places and crashes all over the place. It's awful. I ended up using the Android server from IdaPro, which is also not super awesome because it's like this heavy GUI and it's doing remote through its own protocol, but it does work. So I managed to get there. And so the first thing I did, of course, was try to get the module to like crash it because that's the fun thing. I put some breakpoint in the libstagefright code where I wanted to get, and I found out, hey, I didn't even get there. That's not good. That cannot be good at all. So it turns out that Samsung actually has two separate metadata processing libraries, and they use different one depending on MIME type or the way that the metadata, the media is loaded into the browser. And so I actually required changing some of the code around using this file reader object with read as data URL instead of using the URL.create object URL JavaScript to actually get the media content itself. If we went the other way, it would go through this crappy code path, which would use this other proprietary library, which, by the way, is very interesting. I just haven't looked into it. It's more interesting to me that they have two. If they're going to replace it, you might as well replace it. Yeah. So what else? Samsung also modified libstagefright. Closed source modifications to libstagefright. One particular change was very interesting. Usually in the metadata processing in the MPEG-4 extractor, it goes through and anytime it sees any error, like for example when we try to read that big blob of data at the end of the file and it fails to read the amount we've told it to read, it only reads a little bit and then fails with an error, that will then cascade all the way back to the very beginning of the processing of the MPEG-4 code, and you know it'll always error all the way out. And so in one of the things that Samsung changed was in this track atom, when they're processing it, they were like, well, hey, if there's an error while processing a track, it's okay. We'll just return okay. And so that means you can have tracks that contain tracks and a whole bunch of tracks, and every single track will then trigger the vulnerability over and over and over again. Unfortunately, because of the way we control the data that's written, you end up getting like all the rest of the file in each one of those overflows, and that's not fun, but still, it's still interesting. Yeah, so I didn't end up using that, but I still thought it was interesting. So other stuff was just minor adjustments. I needed to like, you know, some of the object sizes were changed because they added another member variable or something like that. They added a bunch of different metadata items that they just initialized from nothing hard-coded in the code, and so that made the vector overwrite technique a little bit more complicated. If you look at the Metasploit module, you'll see like some various obvious like, you know, hey, if it's Samsung, then do things a little bit differently. So in the end, I managed to get it to work. I had a separate branch in my dev tree, and I like merged it together, and now it works on both. So let's see if we can make the Samsung device get home. Oh, not over there again, is it? I'm bringing this over here. This is mine. I missed it. How did I miss it? You son of a. Oh, look at that. I get to see it now. No, it's, okay, it worked. All right. It worked. So, oh, look, I got another interpreter session. That's great. Thanks. That's the JavaScript detecting that media server crashed and just like running it again. Very nice. Persistence built into the exploit. So we're going to switch here to this SMG900V. And the last time I tried to do this demo, it also failed, but it wasn't. It was because I was getting a prompt on the screen that said like, "This is the first time you ran Chrome. Are you sure you want to like?" I'm like, "Oh man." I think I fixed that now. So again, we're going to go onto the. Oh no, that's not good. Oh, come on now. No, it's removed. Come on. Okay, well, I guess we're not going to do the demo on the Samsung device because it's not plugged into my computer at home. I know it's plugged in, it just must have flaked out, and sometimes those guys flake out. Maybe I can call my mom and ask her to, like, tickle it. Say, hey, moms, can you go, like, push that phone around and, like, unplug it, plug it back in? No, we'll do it later. So I'm sorry I can't give you the demo on that, but trust me, it looks exactly the freaking same. The difference is it says SMG900V instead of whatever, you know, Nexus device. That's really the only difference. So let's see what we got. So future work conclusions, let's wrap up. Let's get out of here. So exploit to do. I've actually started this first one. Mother butt. I do care. You guys will need to see some slides, or maybe, don't you? There we go. All right, thank you, Todd. That was great. You didn't even call me ass or numbers. We need more beer in you. So DL-malloc devices, that's first on my to-do. I'm actually started this already. I set up a dev environment. It looks promising. I had a file at one point that I tested on an Android 4.4.4 device, and it was already crashing with PC control, so that's really, really promising. So, you know the thing with Android 4.4 or 4.x? No, 4.4. Yeah. Which is KitKat. That actually is still like nearly, I think, 40% of the Android device distribution if you trust Google's numbers. And it's still used on a lot of, like, if you go to Walgreens or something and you go buy a prepaid phone, there's a high likelihood that it has KitKat on it. So that's really a high priority thing, I think, for the future work on this exploit. Also supporting additional devices. I have a pile of Samsung phones on my desk that I bought, and I just need to like plug each one in and run the thing and get the offsets. It's not really hard work. It's just tedious work. So I also theorized that it's possible to get rid of the heap spray. There was a Project Zero exploit that came out like last week or so, and that one works even faster than my exploit. So I'm like, oh, cool. And he doesn't use a heap spray, and I'm like, wow, that's great. So I'm pretty sure it's possible to do. I'm just not exactly sure how to do it at this point. And as he mentioned, it's really interesting because he publishes blog posts and he says all these things, and I'm like, hey, I just did a talk on that like last week. It was great. Not the bug, but all the techniques. So it's pretty neat that he came up with all the same things in total isolation. But I think I'm pretty sure that you could put all of this exploit into just one JavaScript file. You don't need Metasploit other than to catch your shell. Or you could do something else, whatever you want. But I'm pretty sure that you could do it all with JavaScript. You don't actually need to make. I don't think you even need to make requests to a web server. I think you can put the media directly in the JavaScript. Yeah, I mean, and you can manipulate it. You can do some more double floating point precision stuff if you really want to hate your life, but don't do that. I recommend array buffers. Those are nice. So other to do, like I really think that system server is a big weak point in Android right now. It's been that way for a long time. Unfortunately, has not been a ton of people really picking that apart. I wish somebody would really just take that on and go nuts with it. The big thing there is that it shares address space with all the apps on the system. So any app that you install, it knows exactly where some various pointers are in system server. So that's a really weak situation. And also system server runs with the highest privileges you can have that are not root, basically. If you ever go and you read through a whole bunch of different Android code, they have lots of things where it's like, if user ID equals 1000, then don't do any authentication, don't do any checking, let them do whatever they want. Wow. So yeah, somebody look at that. Another to do is to mitigate, there's this ref-based technique that was used in the first exploit that I wrote first for the older Stagefright vuln on the older device. And I'm pretty sure that it's possible to mitigate that technique using some kind of encoded pointer or something, but it's some ugly C++ code, so it hasn't been done yet. So in conclusion, I think exploiting the browser on Android is pretty awesome. Exploiting media server through the browser is pretty awesome. You can do info leaks. You have all these lifetime issues are automatically solved for you by the way that Chrome does communications with the browser. Oh, by the way, I heard that Chrome no longer talks to media server on Android, which is kind of funny. They're like, we're just going to do it ourselves. Fuck the Android guys. So in conclusion, obviously, info leaks are workable. They work really well. You can, when you do browser stuff, you can hide in HTTPS. So that gets around, you want me to get the hell out? Get the fuck out. That's what they're saying. I got 4.5 minutes, right? One, okay, one. All right. Skip the slide then, right? Fragmentation is a thorn, but less so for exploit dev. It's a lot worse of a thorn for those guys who are trying to make apps that render properly on everyone's devices with different screen sizes and stuff. For exploits, you offsets. You write a small little script that runs on all the firmwares and you have all the offsets. Great. You just write one piece of code and run it. Excellent. The hard part is you need to gather all the firmwares and you need to uncompress them and have like a lot of files. Okay, whatever. We have hard drives, right? Lots of them, big ones. So patch stuff, patch faster. Thanks, Dave, for helping with that, and all the other Android guys. Android N raises the bar. Something I didn't mention is they actually took media server and split it into multiple components. So now they have this, the way that this code would be handled is in a thing called media extractor, and media extractor actually has very little privileges. It still has internet privileges, so you can still connect back, but it no longer has privileges to make memory read, write, and executable at all. So that makes things really hard. Yeah, so JEmalloc, in conclusion, is very bad. Don't use it, please. I cannot believe that they have not figured out a way to make this a little bit harder to exploit. I like to give the example, like if there were a slider and on one side you had performance and the other side you had security, JEmalloc is all the way to performance. So they're like, fuck security. In fact, like the order of allocations and when you free and reallocate stuff is like 100% deterministic. It's just terrible. So the exploit, it is hereby released. It was released in the previous talk while James and everybody was doing their town hall. It is on, it's in a pull request. I tweeted about it. So it should hopefully be in the tree whenever somebody like reviews it and thinks it's good enough to commit. Yeah, so I hope that people will get involved in this exploit. Try to port it to new devices. I think it's a great opportunity to learn about Android exploitation. A lot of the hard work's been done for you. I think that this exploit could easily be adapted with the newer vulnerability that was released last week to make an even newer Metasploit module for a newer vulnerability. Because this vulnerability is a year old now. So I think there's a lot of opportunity for people to get involved and learn some stuff. So thanks for your time, everybody. I guess we ran out of time for questions. You gonna come up here and jump on me and give me a hug, or I got this for you. Hey man, if you want a hug. Yeah, you too. So you can reach out